Good day everyone, I am Jurland Quitay. I am a third year college student of Negros Oriental State University Main Campus 1. I am taking up Bachelor of Technology and Livelihood Education, major in Home Economics. Today, I and my partner Resa Galapate will report this topic, geology and non-renewable mineral resources. So to give a little bit background of our topic, when we talk about geology, basically it is the science that studies the Earth's physical structure and substance, the history of rocks, the processes that act on them, and the most economic way to use the world's resources. Non-renewable mineral resources are any resources that do not form or replenish in a short period of time. The most common non-renewable resources include fossil fuels like crude oil, natural gas, and etc. Earth, minerals, and metal ores like gold, silver, and iron are also considered to be non-renewable resources. So in connection of this topic, I will discuss to you the crucial importance of rare earth metals, the three major concentric zones, three broad classes of rocks, the rock cycle, supplies of non-renewable mineral resources, and minerals that we can get from the oceans. The crucial importance of rare earth metals. So when we say crucial, it means that extremely important. The mineral resources extracted from the Earth's crust are processed into an amazing variety of products that can make our lives easier and provide us with economic benefits and jobs. Yes, exactly. Just like our cell phones, computers, TV flat screen, and many more technologies that we have right now are the products coming from mineral resources. So through that products, we can benefit it and it can make our lives easier. Why? Because through new technologies such as cell phones, we can use it for better communication. This figure is an example of a rare earth element. This is a lanthanum. So this is the highly reactive rare earth metal, and its compounds are used in a variety of products including batteries in electric and hybrid electric car and lenses in cameras and video cameras. Rare earths are used to make liquid crystal display, flat screen for computers and television sets, energy-efficient compact fluorescent and LED light bulbs, solar cells, fiber optic cables, cell phones, and digital cameras. They are also important in the manufacture of batteries and motors for electric and hybrid electric car. This figure is a car or a hybrid electric car that uses a variety of rare earth metals such as cerium, lanthanum, cerium, europium, yttrium, cerium, dysprosium, neodymium, and terbium. So because of their superior magnetic strength and their other unique properties, these elements and their compounds are very important for a number widely used for our technology. What are the Earth's major geological processes and what are mineral resources? Geology is a scientific study of dynamic processes taking place on Earth's surface and its interior. However, geologist is a scientist who studies the solid, liquid, and gaseous matter that constitutes the Earth and other terrestrial planets, as well as the process that's shifting. So basically, geologist is a person who studies the Earth. So there are three major concentric zones. Number one is core. A core is the innermost zone. It is extremely hot and has a solid inner part surrounded by a thick layer of molten rock and semi-solid material. So example of molten rock is the magma. So this is the first layer of the Earth. Second layer of the Earth is the mantle surrounding the core, and it is thick zone. A zone made mostly of solid rock that can be soft and pliable at very high temperatures. Lastly, the crust, the outermost and thinnest zone of solid material. It consists of continental crust, which underlies the continents, and the oceanic crust, which underlies the ocean's basins. What are minerals and Rock. So mineral is naturally occurring chemical element and organic compound that exists as solid with a regular repeating internal arrangement of its atoms. However, mineral resource is a concentration of one or more minerals in Earth's crust that we can extract and process it into raw materials and useful products at affordable cost. Rock is a solid combination of one or more minerals found in Earth. So rock is placed in three broad classes. So these are sedimentary rock, igneous rock, and metamorphic rock. So the sedimentary rock is made of sediments or dead plants, animals, remains, and tiny particles of weathered, eroded rocks. So basically, sedimentary rock are formed by the accumulation or deposition of mineral or organic particles of the Earth's surface followed by cementation. This is the example of the sedimentary rock. So second one is the igneous rock, forms below or on Earth's surface under intense heat and pressure when magma wells up from Earth's mantle and then cools up and hardens. So basically, igneous rock is derived from the Latin word ignis, meaning fire. It is formed through cooling and solidification of magma lava. Another one is metamorphic rock, forms when an existing rock is subjected to high temperature, which may cause it to melt partially while high pressures, chemical fluids, and or a combination of these agents. So this rock is transferred from existing rock to a new types of rock. So these are the example of igneous rock and the metamorphic rock. So this is a rock cycle. So as you can see, the entire process of rock cycle is melting, cooling, weathering, eroding, pressure, and heat, compacting, and cementing, and melting again. So this is the rock cycle. So mineral resources, there are two metallic and non-metallic mineral resources. So there are more than 100 different minerals from the Earth's crust. So metallic minerals are made of single elements such as aluminum, gold, steel, and copper. Non-metallic minerals are made up of non-metallic elements and compounds such as sand and gravel and limestone. So these are the uses of the aluminum, steel, copper, and gold, sand, gravel, limestone. So how long might supplies of non-renewable mineral resources last? So mineral resources will last depends on consumption rates and reserve amounts. So these are the supplies of non-renewable mineral resources can be economically depleted. So most published estimates of the supply of a given non-renewable mineral resources refer to its reserve. So the reserve can be expanded when we find new profitable deposits or when higher prices improve. Mining technologies make it profitable to extract deposits that previously were too expensive to remove. So we have never completely run out of non-renewable mineral resources, but mineral becomes economically depleted when it costs more than it was worth to find, extract, transport, and process. So at that point, we can have choices. So it's either recycle or reuse existing supplies, waste less, use less, find a substitute, and do without. So this is a figure in which depletion time for. So this is the mineral resource depletion curves. So from curve A to curve B to curve C. So if we people continue to abuse our natural resource, there will be a great depletion of resources or shortage of our resources, just like what is being portrayed in curve A, that there is a high rate of depletion. So can we get more minerals from the oceans? Most of the chemical elements and compounds found in seawater occur in such low concentrations that recovering these materials takes more energy and money that they are worth. So mostly are currently only magnesium bromide and sodium chloride are abundant enough to be extracted profitably from seawater. Then as the hot upping, these deposits are especially rich in minerals such as copper, lead, zinc, silver, and gold. So this is the figure. In this figure, it is a hydrothermal deposits or black smokers that are rich in various minerals.
Environmental effects of using non-renewable mineral resources. Every metal product has a life cycle. For instance, a life cycle of a car. At first, the mining company will mine the mineral to extract the metal ore and separate it from the waste materials. Afterward, it will be processed through smelting, melting, and finally converting it into a new car. Years after, when the car will be discarded, it will be recycled and undergo again the process of smelting, melting, and then creating a new product. While enjoying the new products, we didn't even realize that its process makes use a large amount of energy and water that results in pollution and waste. There are several mining techniques that are used to remove mineral deposits. Surface mining. This cleared away the vegetation, soil, and rock overlaying the shallow mineral deposit to remove it. It can extract about 90% of the non-fuel mineral resources and 60% of the coal. There are three types of surface mining: open pit mining, strip mining, and mountaintop removal. Underground mining. It involves digging down into the earth and creating tunnels and shafts that reach the deposits of ore and other resources. Placer mining. It is generally done in riverbeds, sands, and other sedimentary environments and involves sifting valuable materials from sediments to extract gold, gemstones, platinum, tin, and other materials. In situ mining, also referred to as solution mining, that involves pumping chemicals underground to dissolve resource-containing ore and then pumping it back to the surface. Extracting minerals from the Earth's crust and converting them to useful products can disturb the land, erode soils, produce large amounts of solid waste, and pollute the air, water, and soil. According to the U.S. Environmental Protection Agency or EPA, mining has polluted mountain streams in about 40% of the western watersheds in the United States, and it accounts for 50% of all the country's emissions of toxic chemicals into the atmosphere. Gold mining. In the year 2019, China topped as the largest gold producer with an annual gold output of 383.2 tons, while Brazil is the top 10 largest gold producer with an annual gold output of 106.9 tons. Gold costs a great amount of money. However, its process of extraction through mining ravaged landscapes, contaminated water supplies, and contributed to the destruction of vital ecosystems due to the cyanide, mercury, and other toxic substances it releases. Nanotechnology or tiny tech uses science and engineering to manipulate and create materials out of atoms and molecules at the ultra-small scale of less than 100 nanometers. Nanomaterials are used in more than 1,300 consumer products, and the number is growing rapidly. Nanotechnology may have potential environmental benefits, but it also poses harmful threats to human health and animals. Yu Go is a professor of chemistry and a nanotechnology researcher at the Chinese Academy of Sciences in Beijing. He is a designer of nanotechnology batteries and National Geographic Emerging Explorer. The available supply of a mineral resource depends on how much of it is in the Earth's crust, how fast we use it, the mining technology used to obtain it, the market prices, and the harmful environmental effects of removing and using it. Sustainable use of non-renewable minerals. Some analysts point out the possibilities of finding substitutes for scarce minerals through nanotechnology, as well as through other emerging technologies. For example, fiber optic glass cables that transmit pulses of light are replacing copper and aluminum wires in telephone cables, and nanowires may eventually replace fiber optic glass cables. We can use non-renewable minerals more sustainably in different ways. Reuse or recycle metal products whenever possible, redesign manufacturing processes to use less mineral resources, reduce mining subsidies, increase subsidies for reuse, recycling, and finding substitutes. For example, recycling aluminum beverage cans and scrap aluminum produces 95% less air pollution and 97% less water pollution and uses 95% less energy than mining and processing aluminum ore. Graphene is made from graphite, a form of carbon that occurs as a mineral in some rocks. Graphene is one of the world's tiniest and strongest material and is light, flexible, and stretchable. A single layer of graphene is 150,000 times thinner than a human hair and 200 times stronger than structural steel. It is also a good conductor of electricity and conducts heat better than any known material. The Earth's major geological hazards. The gigantic tectonic plates are somewhat like the world's largest and slowest moving surfboards on which we ride without noticing their movement. Their typical speed is about the rate at which your fingernails grow. Much of the geological activities at the Earth's surface take place at the boundaries between tectonic plates as they separate, collide, or grind along against each other. The tremendous forces produced at these plate boundaries can cause mountains or deep rifts to form, earthquakes to shake parts of the crust, and volcanoes to erupt. There are about 1,500 potentially active volcanoes worldwide, aside from the continuous belts of volcanoes on the ocean floor. Volcanic eruption. The internal pressure of a volcano is high enough to cause lava, ash, and gases to be ejected into the atmosphere or to flow over land that can be extremely destructive, causing loss of life and obliterating ecosystems and human communities. However, it also has benefits, for it can result into the formation of majestic mountains and lakes, and the withering of lava contributes to fertile soils. Earthquake is one of the nature's most powerful events that caused by sudden tectonic movements in the Earth's crust. A major earthquake is a very large rock and roll geological event. The largest recorded earthquake occurred in Chile on May 22, 1960, and measured 9.5 on the Richter scale, where 1,600 homes destroyed and 184 people died or missing. A tsunami, often called tidal waves, is a series of large waves generated when part of the ocean floor suddenly rises or drops. The largest recorded loss of life from a tsunami occurred when a great underwater earthquake in the Indian Ocean with a magnitude of 9.15 caused a tsunami with huge waves that killed around 279,900 people and devastated many coastal areas of Indonesia, Thailand, Sri Lanka, South India, and even Eastern Africa. It also displaced about 1.8 million people and destroyed or damaged about 470,000 buildings and houses. It happens since there were no recording device in place to provide an early warning of this tsunami. Dynamic forces that move matter within the Earth and on its surface recycle the Earth's rocks, form deposits of mineral resources, and cause volcanic eruptions, earthquakes, and tsunamis. These Earth's major geological hazards can't be stopped. However, we must always bear in our minds that awareness, education, preparedness, prediction, and warning systems can reduce or mitigate the disruptive impacts of these hazards in our communities.